Greetings, 7th grade class. Welcome to lesson 95, Slant Heights of Pyramids and Cones. The book does a really decent job explaining this, so we're going to walk through it here on our device. Let me get the pen here. It says new concept. The term height in geometry generally means the perpendicular distance from the highest point of a figure to its base. So if we're looking, the height is from the middle of the pyramid straight up to the top. The height is from the middle of your cone straight up to the top. It is met at a 90-degree angle with the base. Okay? The heights of the pyramid cone shown below are equal. Both are the distance from the apex to the solid point at the base directly below the apex. We use a height to calculate the volume. So, basically what they mean is from the base, straight up to the tippy top, that forms a 90-degree angle to the base, okay? That is used to calculate volume. But now we're talking for pyramids and cones, we are also interested in another measure called the slant height, which is the diagonal distance along the surface from the apex to the base. So from the tippy top down on an angle to the base. So not down the middle, down along the side. So if you went sledding down a pyramid, you would slide down the slant height. Likewise, on your ice cream cone, you hang on to that slant height side, the side of the cone. So not straight down the middle, okay? The slant height. We learn more about the surface areas of pyramids and cones in lesson 100, okay? Now, if we look at a vertical cross-section of a pyramid and cone at the apex, we see that the cross-section is an isosceles triangle. What does this mean? Okay, if we cut a pyramid right down the middle, and we ended right here, and right here, and cut it right down the middle, and then looked at the face that we just created, we will get this shape. All right? And likewise for the cone, we'll get that shape. Now look at what they create. It creates a 90-degree triangle. Because it's a 90-degree triangle, all the properties of a 90-degree triangle stay intact. They work here. So we have a leg A and a leg B and a hypotenuse C, which means we have a few things we can know about this. Okay, one is the hypotenuse is always the longest side of a triangle. C is longer than A and B. So the height and the slant height are not the same. The slant height will be longer. But that also means we can use the Pythagorean theorem. If we know the base and we know the height, we can figure out the slant height. Likewise, if we know the slant height and we know the one base, then we can figure out the height of the pyramid. Okay? Again, Pythagorean theorem, a squared plus b squared equals c squared. Now they show the cross section of a cone. So if you cut the cone right down the middle, that's the shape you'd get. Okay? All right. So example 1, let's calculate the slant height for this one. All right. So again, let's pretend that we cut it right down the middle. So we cut it and we receive this shape. Whoa. You know Mr. Dean can't draw. There you go, roughly that shape. Now, straight up the middle, from the very bottom to the apex, the very tippy top, we find is 12 centimeters. And the base from one end to the other end is 10 centimeters. So we have 10 centimeters there. We have 12 centimeters right up the top. So how do we figure this out? All right, let's go down to what they did. So they took that cross section of the 10 centimeters and cut it in two because our height line cuts it in two. And we're only interested in 1/2 of that triangle. So our height remains the same at 12. Our base for our right triangle is 5. So they plugged in 5 for the leg, 12 for the other leg to get what C? 25 plus 144. So 5 squared is 25. 12 squared is 144. Now that solves for C squared. If this is 5 and this is 12, does it make sense that this is 169 centimeters? Does that make sense? Absolutely not. That is C squared, not C. So how do we solve for just C? The opposite of squared is the squared root. Square root of 169 is 13. That makes way more sense. 5, 12, 13. Way more sense. Okay, so now here they're talking about Armin is building a model of a great pyramid to approximate proportions. The base of the pyramid will be a square 30 centimeters in each side. So they show that 30, 30, 30, 30. He wants the height of the pyramid to be 20 centimeters. So he wants the height of the pyramid to be 20 centimeters. So measuring from the very middle to the very top, he wants that to be 20. They show that here. What should the slant height of the rectangle faces? What should be the slant height of the triangular faces? So in other words, what should be that height right there, the slant height? Let me use a different color. So this and this are the same. Because when you would fold this up, it would meet in the middle. And then it would go down along the side for the slant height. Okay? They got 15 because they cut it in half. Okay, because the triangle cuts it in half. So half of 30 is 15. 15 squared plus 20 squared equals, all right, let me bust out a calculator here. Yeah, I can't do this in my head. Sorry. Maybe you guys could. 15 times 15, whoa, I didn't clear off from. Okay, 15 times 15 is 225 plus 20 times 20 is 400. That I should have been able to do in my head. 625 equals C squared. So the square root of 625, square root 625 equals 25. And that's how they got the 25 centimeter slant height. So if an actual size net is folded to form a pyramid, what would be the height of the pyramid? 20 centimeters. What? Okay, he wants the height of the pyramid to be 20 centimeters. So yeah, okay, they told us that. I was going to say, we didn't figure that out. They told us that. They told us that. So sketched another pyramid, what should be the slant height? The slant height was 25. That we just figured out here. Due to they gave us 30 and they gave us that it was 20. Okay? All right. Awesome. Go through the questions. If you have any questions, go through the letters. If you have any questions, please give me a call. We'll work through it. Okay? Talk to y'all later. Bye.